Bismillahirrahmanirrahim. Assalamualaikum and greetings to Madam and Sir. Today we are going to talk about our mini project, which is developing mini springless car suspension system. Next. For the introduction, suspension is the system of tires, tire air, spring, shock absorber, and linkage that connects a vehicle to its wheels and allow relative motion between the two. Suspension system must also support both road holding, handling, and ride quality, which are at odds with each other. The tuning of suspension involves finding the right compromise. Okay, next. This is how the car suspension function. Car suspensions commonly work by using principle of force dissipation, where it involves converting the force into heat and thus negating the impact on the car's body. The suspension system uses components such as spring, shock absorber, and struts to achieve the damping effect. Springs for supporting the weight of the vehicle and providing resistance to vertical motion, where dampers, which is also a shock absorber, for controlling spring oscillation and absorbing vertical shocks and vibration caused by road inputs. As we can see, this is the common car suspension system, which is in our daily use for cars. As you can see, there is spring and a damper. Okay, next. However, we decide to modify and develop a new way a car suspension system could be developed, which is by replacing the damper and the spring with bearing, which is here, and we just use a small model to create this for our conceptual drawing. Okay, next. Okay, how does our model function? In our project, we would like to introduce a new way a car suspension could work without using any damper or spring. Our idea was to use bearing instead as a substitute, just like our model above. The way our model works is the body part of our model would stay at its original position, even when crossing some bumps or rock, as the bearing would move the side frame up and down. So when the tire obstruct any obstacle, only the frame would move upward, but the body will remain at the position. Okay, next. This is all the parameters that we take. First, for gears, we use a gear ratio 1:1 because we want to make our all the forces transfer to every gear is equilibrium, which is also the same. And this is all the other parameters that we take. Okay, next. Okay, for work, we use the size of M1.2, which is quite small in the diameter, which is 1.2 millimeter, and this is because our model is just small, which is around this size only. Okay, next. The shaft is also small because of our body size. Okay, next. We also use all these components, which is a motor for bevel gear, and the battery, wire, tires, belt, flywheel, body frame, which is the main and the side frame, also infrared sensor for the to control whether to start or to stop the movement of the car. And we also have remote control and the bearing. Okay, that's all from me. Start.
The objective. The purpose of our project is to provide idea for springless suspension system and to provide reference for car developers using mini model. In our planning, we start our project by approach using Gantt chart for project management to get a clear visual representation of the project timeline and activities involved, allowing for effective tracking of progress and identification of potential challenges. Our main focus is on developing gear, bolt, shaft, and bearing as an innovative solution rather than improving existing machines shows creativity and determination. The brainstorming phase, conception drawing, and 2-week CATIA design phase demonstrate the effort and time put into the project, despite a setback with a team member leaving. The remaining members show strong commitment by continuing to work on the project and documenting progress through written reports. So this is our Gantt chart for the first week 8. We planned and decided to do this project, which is springless suspension car, and we start searching and explore more on this topic in week 9 and also week 10, and then in week 11 we start Katia design for 2 weeks, involve week 12, and for the last week 13 and week 14 we starting making a report and video making. So this is our design analysis. This is a bevel gear. So we use 10 diameters for inner diameter, and the width of the bevel gear is 40 mm. Next is our gear that we use to connect with tire, which is used outer diameter 40 mm. Next is bolt. So we use diameter of 0.04 diameter for bolt, and with 2.2 mm height. And lastly, for the shaft, we use the 10 diameter shaft and with 80 mm long. That's it from me. Thank you.
Okay, Bismillahirrahmanirrahim. For discussion, for this mini project, we have created a mini springless suspension car system to replace spring and damper with bearing. We also have many factors we have taken during this mini project, and then um, the calculation that had been done also taken from trusted uh, source, and the formula also we took from the textbook and so on. The outcome of the project is also within our expectations, as we are satisfied with the result of the project in terms of the final design and the final measurement of the project. Okay, next, for conclusion, our project highlights the potential for new and innovative solutions in the field of the car suspension, and it is our hope that our ideas will someday be used for a reference by car developer. Our project demonstrates the value considering alternative solutions and thinking outside the box, and it is a testament to the power of creativity and hard work. In conclusion, our mini project on the springless suspension system has been a valuable learning experience, providing us with hand-on experience, technical knowledge, and critical thinking skill that will serve you well in your future endeavor. That's all from us. Thank you.